Hello everyone. Today we are discussing about queue in data structure. In this slide, we are discussing about introduction to queue in data structure. A queue is a linear data structure that stores element in specific order. It follows the first in first out principle, meaning that the first element added to the queue is the first to be removed. Queue data structure are used in scenarios where order processing is essential. Now let's discuss what is queue. A queue is an abstract data type that stores data elements in a sequential order, where elements are processed in the order of their arrival. It follows FIFO principle. Queue elements are processed on a first in, first out basis. The structure of queue is front and rear. Front, the position where elements are removed, and rear, the position where elements are added. Let us see characteristics of queue. In queue, dequeue, peak, is empty, is full. In queue, adds an element to the end of the queue. Dequeue, removes the front element from the queue. Peak, views the front element without removing it. Is empty, checks if the queue has any elements. Is full, checks if the queue has reached its maximum capacity.
Different types of queues in data structures. A simple queue follows the first-in, first-out principle, or FIFO. Here, elements are added at the rear and removed from the front, following a straightforward order. Next, we have the circular queue. This type of queue connects the last position back to the first, forming a circle. It prevents the wasted space seen in traditional queues by reusing memory efficiently. The priority queue arranges elements based on priority, not just the order they were added. Elements with higher priority are dequeued first, and these queues are often implemented using data structures like heaps. Finally, the decay, or double-ended queue, allows insertion and deletion from both the front and the rear, providing greater flexibility for certain applications. Each of these queues has unique characteristics and use cases, making them valuable for different scenarios in programming. Now let's look at some practical applications of queues in different fields. Operating systems use queues to manage tasks based on their order of arrival. This ensures that processes are executed in the correct sequence, allowing for smooth multitasking and system efficiency. In networking, queues are essential for handling data packets. They manage the order of packets for transmission, ensuring that data flows in the correct sequence. Routers and other network devices use queues to effectively manage traffic. Printer queues work similarly. Print jobs are arranged in a queue, so the first document sent to the printer is processed and printed before the next one. Finally, in customer service systems, queues organize customer requests or support tickets. This approach ensures that each request is addressed in the order it was received, promoting fairness and efficiency. These applications highlight the importance of queues in managing tasks, resources, and data flow in various systems. In this slide, we'll explore different methods for implementing a queue. First, we have the array-based implementation. This uses a fixed-size array defined when the queue is initialized. It's simple to implement but is limited by the array's predefined size. This approach also requires tracking the front and rear indices to manage where elements are added or removed. Next, there's the linked list implementation. Unlike the array, this method provides a dynamic size, which offers flexibility in memory usage. Each element in the queue points to the next, forming a chain. This allows elements to be added and removed without shifting others, making it more memory efficient for large data sets. Finally, we have the circular queue implementation. This approach overcomes the limitations of a simple array by reusing space as elements are dequeued. It also requires tracking the front and rear indices, but wraps around to the start when reaching the end of the array. Each implementation has its own advantages and is suited for different scenarios based on memory needs and the complexity of operations. Let's take a look at the advantages and disadvantages of queue implementations. Starting with the advantages, queues are simple and intuitive, making them easy to understand and implement. They ensure ordered processing, which is ideal for scenarios where tasks need to be handled in a specific sequence. They also provide efficient memory usage. For example, circular and linked list queues are optimized to use memory more effectively. Now, for the disadvantages, fixed capacity in array queues can be a limitation. Array-based queues have a set size, which means they may require resizing or switching to a different data structure when more space is needed. Memory overhead is another consideration, particularly in linked list implementations, where additional memory is used for node pointers. Lastly, complexity in resizing can be an issue. Dynamically resizing arrays can be costly in terms of performance, and circular queues, while efficient, can be more challenging to manage. Understanding these pros and cons helps in selecting the right queue implementation based on the requirements of the system. To summarize, queues are a linear data structure that operates on the first in, first out principle. The enqueue and dequeue operations are used to manage the elements within a queue. Various types of queues, including simple, circular, priority, and decay, serve different applications and needs. Queues play a significant role in many fields, such as operating systems, networking, customer service, and other tasks that require an orderly process. In conclusion, queues are foundational in many computer systems, allowing for efficient and orderly processing. A thorough understanding of their properties and implementations lays a strong foundation for exploring more complex data structures and algorithms.